Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to do an introduction to sequences, a common tool used in mathematics, especially for cryptography and other things like for computer science in particular. So let's go ahead and take a look at this. So imagine, if you will, that I am working with the following function. So let's see here. I got f of x equals 3x. So all I'm doing is I'm just multiplying my x value by 3 here. It's not that deep. So if I were to make a little table for the outputs for this, I would get something that looks kind of like this. That should be a 3x. There we go. So I would have 1, 2, 3, 4 as my x values, and then of course when I multiply these by 3, I would have 3, 6, 9, and 12. So far so good. Now here's the interesting part, and this is where we get to the aspect of sequences. Whoa, what's going on here? Whoa. Oh, something weird's happening. Okay, so I got my 12 here. Now, if I take this guy right here, and I set this aside, and of course you put them in order. And so when you take the results of the function, if you will, and they're all counting numbers, and you put them in order, these are an example of a sequence. So my sequence in this particular instance is 3, 6, 9, and 12, like so. That is our sequence. And so a sequence is a function who the domain, in other words, the resulting y values, if you will, is counting numbers. That's what it is. And so a sequence can be infinite. And normally, if you want to indicate that it's infinite, we put the little ellipses at the end, little dot, 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 like that. Infinite, like that. And so that means it goes on forever. So that means, from 3, 6, 9, 12, 15, 18, 21, 24, all the way to infinity. Now, what we have to understand here is that a sequence, it is a function. So in other words, if I write the following, if I write f of x equals 3x, that's a function, and that can also be a sequence. However, we use a different form of notation when we're trying to indicate that we're working with a sequence. And so that notation is often called the general term notation, or you can also call it the formula of the sequence. And so if we talk about the formula of the sequence of the general term, we're looking at the following. So we'll just put gen term like this. And so it looks something like the following. A sub n equals, oh, that's a little bit big there. Sub n equal, oh, that's ugly too. Sub n equals 3n. All right, so this is the same thing. So what's happening here is that this a sub n is replacing the function aspect of it, and this 3n is kind of replacing the 3x. And so if we were to make another little table here, it would look like the following. So you would have n, always crooked, n, and then you got this a sub n equals 3n, like that. So you put in your 1, 2, 3, 4, and so it looks like the following. So remember, all we're doing is that the n represents this. So a1, if you will, so a1 will equal 3 times 1, which equals 3. That should look familiar. And so a sub 2, which should equal 3 times 2, which should equal 6. And then a sub 3 should equal 3 times 3, should equal 9. And of course, a sub 4 should equal 3 times 4 equals 12. Like so. And it's the same process, but it serves a different purpose. And this will become more valuable as we learn how to find formulas for the general term of a sequence, and we start to explore other ideas related to sequencing using factorial notation, etc. So this was just to provide an introduction into our exploration of sequences as we continue to make more videos and see more things. And so just keep in mind that basically for right now, a sequence and a function are essentially the same thing, but the unique thing about a sequence is that is the counting is like its domain is the counting number. So 1, 2, 3, 4, 5. Now you can have sequences with decimals, but we're not going to deal with that right now. But for our purposes, that's how it's going to be. So in this video, all we did was we talked about sequences and their introduction, and I just kind of explained to you what they were a minute ago, about how they are basically the same thing as a function. But what happens is that the resulting numbers of the domain are put in order from smallest to greatest, and what's happening is that it involves the counting numbers. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.